everyone, let's continue. So as a quick recap, we created our stack class, and in order to generalize it, we added a template, and the general data type that we'll be using will just be called data. So we covered the two private data members, which is the size and values. Size is just a size t, data type, which is a 32-bit integer, and then we have a pointer to data called values. This will be our dynamically allocated array. We also covered the unparameterized default constructor, where we create an empty stack. Then we have our parameterized constructor, where we have a size of 1 and just one value for our stack. Then we have our copy constructor for our stack, in which we take a copy of another stack called S and put it into the values of our internal class. Then we have our destructor, which is called at the end of life. So in this video, we're going to cover two getter functions, how we add data to the stack, and how we remove data from the stack. So first, let's cover the getter for size. So because size is a data type of size t, we're going to say that. And we're just going to call our function size. So we're going to add the keyword const here, so that way when we are returning our size, it never gets changed. Right, because we don't want our size to change unless we want it to change. Then we want to return a data, which can be an integer or a string or whatever, and we're going to call our function top, which is also a const, because we don't want the data that we're going to be returning to change. So here's where it gets a little bit interesting. So we're going to be returning, and since values is a pointer, we need to dereference. So we'll be dereferencing values, but we are wanting to dereference values at the end of the array, at the end of our dynamically allocated array. So in this case, what we can do is that we can do values plus size to get us to the end of the array. But hold on. If we add size to this, if we have a size 1 value, and we try to get the end of the stack, well, size plus 1, if there's no 1 offset, we're going to keep going 1 plus the end of the array. So we need to subtract 1. Right, so these are our two getter functions. So size returns the size, which is just a size t variable. Top returns the end of the dynamically allocated list. So we want to offset our array to our size minus 1, because arrays start at 0. So I dereference values, but I give an offset of size minus 1 to get to the end, and I just return that dereferenced value. Seems simple enough, but here's where it gets a little bit complex. So the next function that we're going to cover is going to be push, and it's a function that's not going to really return anything. So we want to put push, call our function push, but what are we pushing? We're going to say our data called value. Well, what cases do we need to consider for our stack? Well, there's two cases. We need to consider when our stack is empty and we're going to be adding new data to it, and the case where when our stack has a size of 1 or more and we're going to add more data for it. So in this case, if our stack is empty, and we'll define our empty function in the next video, if it's empty, if this is true, then our values is going to be similar to our parameterized constructor. Right? If it's empty, we need to give it a size of 1 and give it the value there, dynamically create that value. But we'll rewrite that here. I'll say new data value, and we'll increase the size. alternatively for this, you can do, hold on, let's make it pretty. You can do this. You can do this. You can also do this. Right, this is all up to you. But I like to use size plus plus. Now let's consider the case where we have more than one value. If that's the case, well, we need to create a data size. So I'm going to say data size is equal to size, right? And this calls our getter function here. Pretty nicely we made it, right? Then we'll continue. We'll make a copy of the data copy. And this will be, we'll allocate some space for it, data size. Since we're taking a copy of it, we want to make an array of the same size. So here what we'll do is we'll create our int I. This should be size t. For I equals 0, I less than data size, I plus plus. Right, and we just want to copy the data here. Data copy plus I. We're putting it there. So why are we actually doing this? So in order for us to reallocate the data for this dynamically allocated array, we need to delete it and reallocate a new size. Right, so here we're going to take a copy just to be safe. So our data is nice and secure somewhere else. And now here, well, we'll just get rid of the data before it. And we'll allocate a new array in place of this now. So values will be reallocated to data size plus 1. Why is it plus 1? Well, because we're adding a new value. So here it is important because we're adding to the end of the dynamically allocated array that we preserve the data that was already there, and we copied it verbatim like it already was. So essentially what that means is that, well, we'll just do this. But we're going to flip it. We'll flip it, and we'll paste it, and we'll grab this, and we'll put it here. Right, so data copy is going to be copied into values. What's different in this second for loop right here is that values has an additional size because we reallocated the data for it. Since I is still existing, and when we exit this for loop, data I will be equal to data size, we can just do this to set it equal to the end of data. Values plus I is going to be equal to value. Right, so this will add value to the end of the dynamically allocated array. In this case, we're going to increment size, pick your favorite flavor of incrementing size just by 1. And because data copy is a local copy of a dynamically allocated variable, right, see line 69, for that, we need to free the memory, and we do that here. And that's really all we need to do for pushing. But let's reiterate over the idea. The idea here is that here we create a copy of the data. Here we copy the data. Right? We free the memory and then reallocate data so that way we can have our original data plus 1. We copy our old data back to where it was, so it looks like we did nothing. But now on statement 81, on line 81, here's where we add, here's where we actually do the pushing of the new data. Right? And now we can do this because we reallocated data to accommodate for our new value. We increase size and we delete our local copy. So this is pretty neat. right? This is kind of like a pushback. We're adding to the end of the dynamically allocated array. If this was a linked list, we would just be adding to the end of the linked list. Right? So now comes pop. Pop, now we're getting rid of what's at the end of the array. We're just getting rid of one thing. So the first thing we got to do, we got to check if it's empty. Now, for this case, you can raise an error, you can just return, you can do a whole bunch of stuff. For this case, we're going to keep it simple. We're going to say could not pop an empty stack. And that's it. We'll keep it simple. We'll just return like nothing's ever happened. But if it's not empty, well, we need to be a little bit more considerate. So actually, there's two other cases that we can consider. If the size is more than 1, we'll have a very generalized way of deleting the data. But if the size is 1, we need to make sure that it's empty. So else if size is equal to 1, well, now we got to delete values. Right, we'll set values equal to null. And we'll set size equal to 0. You could decrement size here. I'd rather not. I just would rather directly set it equal to 0. Get rid of any ambiguity. Right, so now we've covered 2 out of 3 possible cases for the stack if we want to get rid of data. If it's already empty, we need to let the user know that it's empty and do nothing. If the size is 1, well, we need to ensure that this becomes an empty stack, and this is how we do it. We set values equal to null and our size equal to 0. So now we need to consider the case where we have more than one value. So if this is the case, I'm going to create another data size. And we'll call size from here. We'll take yet another copy of the dynamically allocated data. But now I'm going to get a little bit clever. I'm going to say data size minus 1. Right, why is this the case? Because, well, the data that we're going to be needing is everything except the last element. And, well, this is how we'll do it. I'll create an iterator, I, and have a for loop. So I equals 0. I less than data size. Minus 1. Minus 1. Because here's essentially where we'll do the pop effect. Because we're just going to not copy this data over. Right? We'll get rid of it. So I'll say data copy plus I is equal to values plus I. Right, so this array goes up until the end, but minus 1. So the second to last element. So this for loop is essentially, when we reach the end of it, this is essentially doing the pop action for us. It gets rid of the last data because we're not copying it. Right, so we'll free up the memory and immediately we'll allocate new memory, but it'll be one less of the original data size. Right, then we'll copy the data back over. Right, so now that the data is copied back, since data copy doesn't include the last element of data, we just don't include it at all. So from there we're good. We're going to delete our data copy because we don't want any memory leakages. And we'll decrement the size. Right, so this is how you'll pop data off the stack. And as a quick review, let's start with pop, and we'll go back to push and review both. We'll review the functions that we've just created. So with pop, we need to consider three cases. When the stack is empty, where we'll do nothing because there's nothing to pop because there's no data there. Then if the size is 1, well, we need to make sure that that the stack goes from having data to making sure that it's empty. So we have a specific case for that. But then we have a general case where the size of the stack is more than 1. And what we'll do is that we'll take a copy of the stack, except we'll exclude the last member. And by excluding the last member, we're essentially popping it. We're essentially removing the last element of data. And we'll reallocate data for our stack, and then we'll copy it back. And because we've already omitted the last element of the stack, that was before we popped it, we're good. The last element is gone. And we'll decrease the size. Finally, we have the push, which we only need to consider two cases. When it's empty, we need to make sure that the data is allocated there so that way it's no longer empty and that our size increases. Then we have a case where the size is just more than 1, and what we'll do is that we'll take a copy of the data, we'll delete our internal data, we'll resize our internal data so that way we can accommodate for this new data, copy everything, and here we'll add our new data to the stack. And then we'll increase the size and we'll delete the data copy. And here we have our nice2getter function, which is the size. It just returns a private data member. And top, well, it returns the end of our values dynamically allocated array, right? So values is a dynamically allocated array. What top will do is return the last element. So in the next video what we'll do is that we'll cover three functions. A function to print the stack, a function to determine if the stack is empty, and a function to search the stack for a particular value. And if the data is inside of the stack, it will return true. Otherwise, it will return false. Thank you.